Everyone, I am Mesombas and topic of my case study project is PLC and Ladder Logic Diagram. PLC stands for Programmable Logic Controller. It is an industrial digital computer control system used to automate a process or a machine. It monitors the state of input devices and on the basis of decisions stored in the custom program, it controls the state of output devices. It is designed to operate more than one input and output arrangements with the immunity of electrical noise, and it can resist high temperatures, vibrations and impact as well. Moreover, it also enables process to be changed or duplicated while simultaneously collecting important information. And the history of PLC is from 1960s as it was made to achieve the demands of automobile industries. As at that time, control systems were made up of relays and circuit-based dedicated controllers. It was a very risky process to change or update any operations with relays, and as even one faulty relay or an unwired circuit loop results in the breakdown of whole system. Finally, in 1968, a company with the name Modicon built the first PLC for GM Hydramatic Car Industries, and Dick Morley is regarded as the father of PLC as he was a part of that project. And the block diagram of regular PLC is shown here, which consists of five main parts: the CPU, power supply unit, memory unit, input output module, and the communication interface. And the programming terminal shown in the diagram can be any computer that can be used to send program code into PLC. In the next slides, I will briefly explain each of the units. So starting with the CPU, which is the brain of PLC, and the CPU controls and supervises all the operations within the PLC. That includes reading the status of input terminals and energizing or de-energizing the output. It performs all the mathematical and logical operations, and moreover, scanning application programs and communicating with the terminal. Programming terminals are also the tasks performed by CPU, and it is controlled by operating system software which is permanently stored in its memory. And PLC memories can be subdivided into at least five major areas. First one is executive memory, in which the operating system is stored by the manufacturer, which really needs any changing. It helps the microprocessor to interpret user program symbols, instruction and maintain the current health status of the system and its components. And the second one is system memory, that is allotted for system administration. As the operating software performs its duties, it often requires a place to store intermediate results information. So a section of RAM is installed for that purpose. That can only be used by operating system. And the third one is input output status memory, which is the another portion of RAM that is allocated for the storage of current input output status, that contains input output image tables as well. And the fourth one is data memory. This data portion of memory is allocated for the storage of timers, counter, preset values, mathematical instruction data, and the process parameters. And the fifth one is user memory, that is allocated for the storage of user program, and it consists of RAM and EEPROM ROMs. And the third unit of PLC architecture is the power supply unit, that is essential component for running the PLC, as it provides power to the input output modules and the processor. It contains electronic circuits for rectification as well. And the fourth unit of PLC is communication interface, that is required to collect and send data onto the communication networks as shown in the diagram. It is used to connect two different PLCs. And the tasks performed by these modules are device verifications, connection management, and data acquisition. And the fifth part of PLC architecture is input-output module. These modules are used to provide interface between the input-output devices and the CPU. And the information that are coming from input devices are transferred to processor through the input modules, whereas the processed outgoing information from the CPU is transferred to output devices through the output module. System conditioning and electrical isolations are the fundamental task of these modules. And for isolation, opto-isolator circuits are used, whereas for signal conditioning that is used in this module are shown in the block diagram, in which the input interface modules take the signals from the input devices in form of AC voltages and then convert them into DC signals that can be used by CPU. Same way the output modules were in vice versa. Now the question is how PLC operates. So basically it operates on PLC scan cycle, which is executed by CPU of PLC over and over again. This is a scanning cycle that is composed of 4 basic steps: read input scan, execute program, output scan, and housekeeping. I will use the figure shown here to explain the cycle. The first step is the input scan, during which the current status of every input module is stored in the input memory table. Then in the second step, CPU enters the program execution part, where it executes the logical program written by the user, and on that basis it updates the output memory table. Then in the third step, updated status of input output memory table is transferred to the output module, by which output devices are energized or energized accordingly. Finally, in the last step of the cycle, internal diagnostics are done, and if these internal diagnostics and housekeeping process are successful, the whole cycle is repeated. In this way, the PLC operation is performed. Now coming to ladder logic diagrams, it is one of the languages used to program the PLC. Basically it is a graphical language that was developed to understand the logic made in relay-based control system. And initially it was having contacts of switches that mimic the opening and closing of relays, but now this language has included several operators as well. Its name is derived from the ladder having 2 vertical rails with the number of horizontal rungs in between them, and the rung in the ladder represent a simple line on which logic instructions are executed sequentially. The context in this refers to the input coming from the physical devices, whereas the coils refers to the output going from the PLC to the physical output devices such as actuators. And the figure on the right shows the example of a ladder diagram in which the square bracket refers for making contact, and the square bracket with backslash refers for breaking the contact, whereas the round bracket shows the output coil. And although it is a sequential logic, but the conventional logic gates of Boolean algebra are used as a tool to assist in its design. And usually for implementing any logic, first a Boolean equation is made, then that Boolean equation is converted into ladder diagram. For example, to operate the RO coil present in the second rung, a combination of OR and AND gates are used as shown in the diagram. And the applications of PLC and ladder diagrams are various, as they are used in food processing, conveyor system, parking control system, and robot manufacturing industries. And to summarize, we can say that PLCs, due to their reliability, easy maintenance features, and flexibility, are used to automate any control process in the industry. And ladder logic diagrams are the most common language used to program it, due to their simplicity and ability to express combinational logic with ease. These are some references, and thank you.